No. Okay, so again, this is the kids who need a fourth-year science to get their full-ride scholarship, but don't want to take a dual-credit course, biology course, and it's their only option for it. It's basically their only option. They could take astronomy, but none of them did. Don't want the full-ride. So there's a weird mix of kids, from the kids that just know that they want to go to college to kids that are really good at science that don't want to take biology because it's not their interest. It's essentially... I'm supposed to talk about this.
Just the prompt, like what led to
it's essentially the exact same thing. The major differences are that we have 5 columns that, like we talked about, have the intervals of time in there. Essentially the same questions as well, essentially the same data set. The main difference is I have no wrap-up activity like MarkCat that had those questions that were valuable.
Cool. So clarifying questions. We got a minute.
As I look around.
So in this case, the kids had no additional help to start to figure out what to do in this data table until they then started to ask you questions. So they were just following this.
They're just following this.
Okay. When did they start to need help? Like what questions?
If I had my computer, I could show you.
Mine, it was 10.
Yeah, I'm around there, 9, 10.
Right, because you have the average velocity in either or both.
Did some of yours get stuck at 8?
Is this yours? And you can see that by the erasing that happens. That's about what that's at the bottom of that first page. And this does kind of help them walk through each column and look at it. Like do this monthly term. I would say that most of these kids are not confident in their physics understanding and abilities. I'd say the confident kids in the school would say, I'm going to take a dual-credit class. These are probably the kids that are less confident in physics.
How many kids are in the class?
12, 14.
Any other clarifying questions? Okay, so at this point, I'm going to say let's take 5 minutes, or no, let's take 5 minutes in silence to look through this stuff, and we'll write down our warm and cool feedback, and then we'll check in and see.
I'm going to make all 4 of them available. If you want additional ones, I have them, but I tried to pick a range of students.
Okay.
They might all happen to be female, however. No.
To clarify, the answer to question 10, the correct answer is yes, it's average velocity.
No, it's not.
It's not.
It is. It can be average velocity in 1. It cannot be average velocity in 2.
Okay, and that's average velocity in that previous time interval. It's not that.
It cannot be calculated as average velocity.
Okay, it is the instantaneous velocity
at that time.
At the middle point of the time.
No, at the time.
At that time.
Because this is at a time, not during an interval.
Okay, got it. Yeah, sure.
As a timeout side note, we should look at 08s because they originally offset theirs. We should see what their columns are.
Yeah, we stole that idea.
They've probably done it more than us. We should
It's true. All right.
maybe tomorrow.
If we're working on it.
I'm my life being your resource teacher.
The official career snack lady.
Nice.
This is a good, special little feeding packet. It's like a doggy treat from London. What was that?
I didn't have Swedish fish. I knew the next best thing. I gave Nicole her bowl of these at breakfast. I didn't bring any pretzels for Kim. She's on her own this weekend.
Yeah.
Okay, that's time.
Okay. Okay, so now we share information with each other, and so we're starting with warm feedback, which is things that we think, how did this work reveal student understanding about the concept of that acceleration and velocity are different things, and then we can move on to cool feedback.
I just want to start with one that I like in some of these, and I'd like to see if we can find a better way to do it. The ones who actually put units on here, I thought that was very telling.
Yeah, I think you're right, because particularly the kid who really, I think, already knew what acceleration was and talked about centimeters per second squared. I think the other thing that shows really nicely, even though I think it was this person, no, it was this person. I don't know if these people worked together. Taylor on the first model says G is acceleration, whereas G over here is change in acceleration. And then Kylie says change in acceleration for both. And so, to me, like, having them label the two data tables separately and seeing that there's a difference between the two labels really like shows that kids are thinking, well, there's something else that's changing. Acceleration still can't be constant if there's something that's changing about the motion, which I think.
Yeah, it's telling, but
yeah, but
wrong.
But it's wrong.
Yeah,
but it's telling about what you're saying.
Yeah.
So I think that's nice that is there. The other thing that I noticed about this is kids use the word rate a lot, and I wondered if they had come up with this or not, because in the 3 that I looked at for when they were asked what is acceleration, a lot of kids said the rate at which an object changes velocity, or acceleration is the rate at which an object changes velocity.
I will tell you, when I did the identical one in my class, I didn't notice any of that.
Like no one said rate.
I didn't notice it.
Okay. Can we ask, was that something that came
I think
about
that was
from
a
prompting?
diffused one.
Okay,
I
someone
may
figured it
have
out.
said rate.
Okay.
But
I don't use that, so.
It may have been a diffused word.
Yeah.
One student caught it.
And then everybody else.
I had one use it on the flipbook day, but it didn't show back up on this day.
Right, somebody says rate of change.
Yeah. And then also one thing that I noticed in question 12, when we leave it open-ended, like how's column G different from column F? One kid puts an equation. One of these kids obviously work together. This kid is talking. This kid identifies that G is acceleration, F is change in velocity. So it's really interesting that I think question 12 is the one that gets us to really hit on, okay, acceleration is the ratio of the change in velocity to the change in time, not just the change in velocity. But like, I don't know what these kids were thinking, velocity over time equals distance? Like, where does that even come in? But then for G and F, they said, oh, G is change in acceleration, but that's the first time that they mentioned that word acceleration.
And what's surprising about that, mine don't mention acceleration until they've done this.
Right.
It's like in middle school,
So I wonder
they never
if they
learned that word. I don't know.
Or not.
Yeah. That's a good thought, whether or not they came back.
I mean, it looks like they erased something, so
Yeah.
it might have.
Where the word acceleration came from is
Yeah.
day before on the flip book, somebody says it's acceleration. And then that word
and then
become a part of the class.
one thing, and
So then they said, oh, they just said, cued, we're not doing velocity, but we're doing this thing called acceleration. So every kid from then on used the word
started to use it.
for something different.
Yeah.
Whether they knew what it was or not, they just started.
I'll say one thing that was really useful that Lindsay and I did, we said, we know everybody's heard of this word acceleration. We made it explicit at the beginning. The point of this is for us to build up an explicit definition that we then all agree on. So we're going to ban the use of the word, even though you guys have heard it, we talked about it, we kind of
Did that work well?
mentioned it. And that seemed to work well, at least, push them away a little bit from saying, oh, this is acceleration, this isn't. And so that's maybe why I got some of my kids to say things like, oh, it's the change of position. Because I said, you can't use the word acceleration.
Until we know what it is.
Yeah. Other warm feedback?
I forgot to start the timer, so.
All right. Should we move on to cool feedback? So things like I wonder. One thing that strikes me, and this kind of relates back to what I was saying before about why it's really nice to have the 2 separate tables for them to fill out, nowhere does it ask about, and nowhere do they talk about, I divided by 2. Like, so even though they get this idea that, oh, it's 12, 12, 12, 12, 24, 12, 36, nowhere do we explicitly ask them to say, what do you notice about this column? Oh, they're all the same. And how does that work out? So I wonder if there's a bridge that's missing there.
Being explicit maybe about getting them to tell you how they what do they do to get from one place to another? Asking that explicit question, I think that's a very good thing.
Because I think we allude to it in the...
No, you're right.
How's column G different from column F, but I think we might need to have some more scaffolding around
I have
12.
questions 19 through 21. I don't remember what they are right now, but I feel like that may have been one of them at one point.
Okay.
Maybe I just didn't ever send 19 through 21, or maybe you didn't like them, I don't know.
Yeah.
We should look back at that at some point when we get into that. But yeah, I think that's a really, I agree with you, Mark, that is definitely something that's missing and could be improved.
Right. Particularly because I think it addresses the weakness of the one that I did, in that there's ambiguity between, is it just delta V, or is it delta V over delta T, is it whatever.
Cool feedback.
Places where there's like a disconnect or a break between what we think they're thinking and what they actually want. Where can we like get more information about?
Yeah, and I'm not sure, just based on all the ones that I read when I took them up, I don't know how easy, it was not easy for me to read their answers and know what they were thinking on these questions. I had trouble figuring out, do you get it, or are you just putting words down right now?
Okay.
So, and I don't know, I felt like the questions you had on yours were a little bit more telling. But maybe it's just because I hadn't seen them before. I don't know.
Possibly.
Just to clarify, the 4 questions at the bottom of Mark's that he added, is that what you're saying, are more telling?
Or you're saying even the other ones?
Even the earlier questions are
Even
different.
like number 2, like this guy right here. Pretty much everything besides past the match the titles.
Yeah, well, these are exactly the same. The extension question ones are exactly the same as here.
Okay.
So, those,
yeah.
based on what you learned, was acceleration, assuming the pattern continues, explain what column E. I dropped out the column E can actually be found from the graphs because I didn't have column E.
Oh, that's right.
My idea may be there, and I'm not looking it up, but I'm going to.
Yeah,
Sorry. Is that we've got that word dropping of acceleration.
on the previous day, you're saying?
Yes, and now they're just saying, and that's why you ban it, is for that exact reason. Is if I don't understand it, I'm going to call it acceleration, and that's going to take
It's going to be a catch-all.
rather than banning that word and having them forget it. Because they were saying stuff, and I was having the same situation while I was leading this, was throwing out acceleration, but I was just kept trying, say it in a different way, try and do it a different way, but they just kept saying, well, this is acceleration, it's got to be acceleration. I'm not recognizing that it was different, but not how it was different.
Maybe that's,
You can see that when you look at like this kid. What is acceleration? It's a movement, and how long it takes to get to a point.
Right.
And I
So
know-
no matter how many times you ask, well, what does acceleration mean? Say it a different way. They just keep going up.
And we intentionally said, based on what you learned from completing a chart, but they all disregarded that first clause and just read, what is acceleration? None of them looked at based on what you learned from completing the charts, because that's why
like
we
using the phrases
worded
that
it
they
that
put at the
way.
top.
So we need to ask that in a way where they have to either relate it back to the chart or something like, how did you figure out that definition from what you did in this activity, or what did your group talk about doing this activity that led you to this something where it's not just okay, word, what's acceleration? Oh, I know
that's
that
what
one.
this is.
Yeah.
Some ways to say that it's interesting to think of different ways to do that, because I think that's you want to give them enough guidance on that so that it's clear that they can't just like whip out the word.
Right.
It's like what is your evidence?
Yeah.
What is your evidence? What evidence did you develop as you went through the chart that you did?
And that might be a better check-in question.
Yeah.
They could do like a video check-in. Say, okay, when you get to number 15, go through your packet and show us how you figured out what acceleration is. Tell the camera and I'll look at it later. Or call me over and check in. Or I would hesitate to go to another group at this point. We'll all be in different places. But we might want to consider just reformatting that a little bit.
Because I feel like there's two things that we're trying to get at, and we got to figure out if we want to get it on both. Are velocity and acceleration different? Because I don't think we have any questions about that. And this kind of question, like, where's your evidence that velocity and acceleration are different? And C, do they point to the chart? Do they point to the table? Do they point to the mathematical description? Do they point to what it looks like? But then the second part, how is it different, right? How is it calculated? like, there's a difference between asking what is different between this, and then what is this. So I don't know if we want to get to the point where they're just saying acceleration and velocity are different because of this, but if we want them to be able to name the thing as acceleration, we have to understand what they think acceleration is. So maybe we have to then still have the what is acceleration, but maybe that comes after how is it different from constant velocity, and I don't know, maybe we even start by having it be open-ended. What is different about these two kinds of motion? List 3 different pieces of evidence from the chart and see if they can put that into words, and then maybe have them massage that to get to the point where they now can say, well, I can define acceleration by saying that it's different from velocity because I know what velocity is.
You got to see how this fits with your role. Like some questions that might lead you to think about the idea. Did you choose the word change in there?
Yeah.
On the other, like, what is changing when an object is moving with constant velocity? And what is changing when an object is moving with constant acceleration?
Because I ended up being like, what is constant about this motion? And that's tough.
It's confusing.
Really tough.
For me.
I mean, both of them are talking about change. Something's changing.
I like that. I
Right.
like that better.
Because then we could talk about change, but then we could also contrast that with rate of change.
That's the key.
Because
You start to think about what is changing, and to then make the next step is to then talk about the rate of change. And sometimes it's really fun to get into those stories. Sometimes you can get them to stories about that. Give an example where, a real life example where you have identical changes in velocity with different acceleration.
Oh, that would be a really, really good formative assessment piece to see if they get the ratio idea.
And it can be just totally conceptual too, because like one of my students told a story last year actually. Said like, well, we're driving down Western Avenue, big street in town, and if I'm driving with my mom and we're at a stoplight, right? If we go when the light turns green, we can go from 0 to 20 miles an hour. It might take us like 10 seconds. Right? Well, I'm driving, I go from 0 to 20 miles an hour, it takes me like 2 seconds. And it's the same change in velocity, but a different acceleration. There's a rate of change. Getting them thinking about that, and so if they can tell stories.
Right.
That might help them to make that connection too. I think if I can understand, guys, you guys have been doing this all along, and it's always hard to come in and go, you should do because I think you do a lot of things right here, for sure. I think maybe we need to be a little bit more explicit in helping them to see the connections.
Maybe that's something we can do, like if we look back at our learning goals to say where are the connections that we for sure want them to make and how much support do they need to make those connections, like where are the bridges.
Yeah, I think we're highlighting those points, but we're doing it in our way of, we understand it, writing those questions. So we know what we're trying to say.
Oh, I see what you're saying.
They don't know what they don't say. We say, based on what you learned from completing the charts, what is acceleration?
Yeah.
We have 5 things that we want them to pull out of that.
Which, as a side note, is a good reason to have an interdisciplinary POGIL team at your school. You can give it to the history teacher and say, hey, how's this work for you?
Interesting.
I think I'll try that.
All right, as facilitator, any other cool feedback
Moderately successful.
that stands out that we need to put in before we turn it back over to London?
We already
that's
have.
right.
All right, let's turn it back over. So, London response.
I
to all
concur
of
with nearly everything that's been said. It's been good. Let's just move on to the next step.
And scene.
Yeah. Oh, yeah.